First of all, thank you for having me here today. My name's Emma Stewart. I'm a Chief Power Grid Scientist at Idaho National Lab. That sounds very lofty, but what I do is essentially I know a ton about how the electric grid works and somehow fell backwards into working on how cybersecurity works in the electric grid as well over the last few years. I've got a lot of interesting experience. I've done everything from climbing wooden poles from an electric utility up to now being this chief power grid scientist. So don't hold the PhD part against me. I've done a lot of different things. But today I'm really talking about what digital transformation means in energy delivery. So really how we're delivering power is changing. There's a lot of different things happening that are driving this around from trying to make it clean. I'll talk about this in a second, but we're looking at how to clean up our power grid and how we deliver energy. We need to make it affordable and equitable. There is about a large number of people in the country that can't actually afford for their power at the moment. So how do we make it affordable and equitable with a clean energy transition? How do we actually make it reliable and resilient? There have been weather disasters, a number of them over the last, well, forever. But we're looking at how to make it more resilient. At this point, we have about 600,000 people today that don't have power just because of a weather event. And then how do we make it secure? That is on the bottom for a reason, because for a very long time, we've been looking at how to do all of the other things. Security has been kind of coming as an afterthought, but now we need to put it at the top of our thoughts. How do we make all of these things secure all at the same time? So everyone has more expectations of how we deliver energy as well. We need more power. We need more reliability. We need more independence from foreign adversaries. We also need more choice. Right now, when you look at the power grid, it depends. You can make a choice of how you put solar in your house, for example. Everyone wants to make that decision themselves now. It's not just how it gets to your home. It's also way more complicated. If I gave a talk on this a few years ago, I'd show a picture of a large spinning generator going down to your house, and that's how it's fed. Now it's way more complicated. There's electrons flowing all over the place. So the themes of what I'm going to talk about today are really decentralization, digitalization, and decarbonization. And saying that in a Scottish accent is not that easy, so bear with me. So trends in our electric grid. I was walking around. I go to two different types of conferences. I'll go to the power systems one, and I'll walk around and work out the trends that are going on over here. And I'll go to the cybersecurity conferences and try and work out what's going on over here. When I go to both of these things don't cross that often, but one of the things that did cross recently was looking at robot dogs. I thought this was really cool, but again, it's one of the big changes. We're now looking at things like robotics and automation going into our substations. We're looking at big data and load for that big data, looking at mass orchestration and industrial control systems. So how do we control billions of devices out there on the system all at the same time? And then again, communications and security. One of the things that I think is most interesting about how the electric grid works as a sector, we have a lot of dependencies on customers to do things. So customer-owned resources, when you put solar or storage on your house or an electric vehicle, or you use your load in your house, just turning on your AC, that's your resource. You're the customer. You want your house to be cool. If you look at how we're serving in some emergencies, how the electric grid works, electric sector or energy delivery is the only sector where we depend on humans to do things and do something for the greater good right now to serve an emergency condition on the main system. So in Texas or even in California recently, you'll get maybe a text message or an action that, hey, can you turn down your AC? We need you to go from sitting at 69 degrees up to 83, sorry. The grid is failing, do this, please. Great. People do it. They're starting to do it a bit less now because it's been happening so often. We're asking those customers to take this action, to sit in discomfort themselves to help serve the greater good of the electric grid. We don't do that in other industries. We essentially, your water supply to your house, you don't feed that back into the electric grid. You don't look at how you're going to use your water to serve the greater good. For one, I wouldn't trust a single one of you with pumping water back into the water grid system. I don't think that's a good idea. So I wouldn't trust myself either. I don't want my water going back into the bigger system. So when we're moving towards this distributed architecture in future with distributed generation, we're trusting those customers to push that back in, but also to manage the security of those devices that are sitting on their houses, pushing back into the bigger system, both from a communication standpoint and from an electric grid standpoint. I put a picture of a bridge up here. Everyone's like, why is that a bridge? That's nothing to do with this. I'd use the bridge analogy a lot, basically saying, if you were told that bridge was going to fall down if you didn't drive your vehicle across it, would you do that? Would you go, like, you need to go and drive your vehicle across it. We'll pay you 1 cent on the dollar for doing that for your vehicle. Please go and drive your car across that bridge. You'll save the big bridge. I don't know anyone that would really actually go do it, apart from some psychopaths that might think it's fun to try it. So some of the other trends that we're seeing, data is queen. I say that on purpose. And there is a ton of it available. When we look at an electric grid system now, it's not just we can't see anything. We can see tons of things now on the system. A lot of it's being made public as well for lots of reasons. One of the pictures here is it's in the California area, a map of what the electric grid actually looks like. We like to pretend people don't know what the electric grid looks like as a security measure currently. That's not really true. Most of it is on the internet. We can see what it looks like. You can look at Google Maps. It's not hidden. We also have data for things like, on the right, that's me showing what an infrared scan of a transformer looks like when they're trying to look for heat problems. We have measurements coming from all of these devices. We have written things that would come from, like, similar to a doctor's note. Field crew write notes all the time about things they actually see when they're out in a substation. Interpreting those is now, it's an AI task. People are using large language models to essentially interpret weird written notes from field crew. But we have a ton of data, and there's a lot of it available, and it's one of the biggest trends now is how do we manage the massive amount of information and secure the massive amount of information and secure the right part of the massive amount of information to keep the system going. And clouds are everywhere. Everyone who has a new type of equipment, a new type of management system, it's going to be cloud-based. There'll be some connection to the cloud. There are very few things that are not using some form of somebody else's computer to manage the data. A lot of utilities can't manage that data without the cloud. So we've got kind of two worlds going on here. In the large utility space, yes, they might have a data center, they might have something in their own location. In the small utility space, there's about 3,000 utilities in this country. About 900 of them are very small. They can't modernize without using the cloud. They're not going to build a data center. One of them actually did have a tornado go through a data center that they had built, and they lost that one, so that wasn't good. But we have all sorts of things going on there on using the cloud and securing that. One of the biggest changes I think we're going to see in the next, by 2030 actually, is massive load increases in different places, partially because of data centers. They're going to be everywhere. They're hyperscale loads. I think I was looking at some stats of what we think is coming for these, and I was trying to give a good metric. I was like, oh, it's going to increase to 20 gigawatts. Trying to explain what that number is to people at a cybersecurity conference doesn't always make a ton of sense. So I was doing it in terms of the two places I live. One, it would be about the size of 6 Scotlands attached to our grid now. 6 of the country of Scotland, the same load attached 6 times, or 1.7 Virginias, put it that way, with Virginia being a state, not a person's name. We're also in a cycle of modernization where we're talking about modernizing this equipment on the electric grid. Awesome. We're also saying AI is going to fix all of it. I'm sure that's been said like 92 times. It's also going to kill us in various ways. Everything needs AI. So, okay, AI needs data centers. Awesome. Data center needs a big grid to serve that load. Excellent. How are we going to modernize the grid to serve it? AI. So we're in this cycle of how we're going to build these new systems as well. That's, it's growing. It's coming. That map on the left is basically the planned and existing centers just in Virginia. There's a data center alley essentially forming. That's a lot, and we need that. So I mentioned what's the current state of our grid. Again, this is what are we at? What's the current state? What are the trends? We have around 3,000 electric utilities in the country. They're split into 3 different business models. There's the 900 small electric co-ops, for example, serve most of the persistent poverty counties in the country as well. But we have been pouring money into this. There's about, I should have changed this, but 1.2 trillion, not billion, going into modernization of the electric grid. We are very focused on clean energy. We need to clean it up. We have had weather disasters everywhere. Climate change, whether you believe it's driven by humans or not, is happening. We need to do something better. It's kind of split with this focus on clean energy. Some love it, some hate it. There's lots of arguments. We've got one half screaming that we want more coal, the other half screaming we need 100% renewable energy. From my perspective, everything's in moderation. We should be somewhere in the middle of this to make it make sense, but we're kind of split just now politically. There is also misinformation everywhere. When Texas had an event recently, one of the things that was said was, well, the sun just went down too quickly. Sorry, what? Like misinformation about things is just everywhere. This happens in cybersecurity. We'll talk about there being an issue with one type of vulnerability, and it will lead to people saying, but it's going to take down the entire power grid if this happens. And we're like, is it? Like, do we think it will? Have we looked at physics? And so, you know, misinformation flies around all the time, and it causes people to go multiple directions on the electric grid. I'm also concerned because I have to sit down and have dinner with people who've never actually looked at the electric grid, like my parents, and they'll be telling me things like, well, we've heard that this is going to happen and we're not going to have power next year. I'm like, what? So there's a lot going on. But the electric grid and generation contributes to about 35% of our global emissions. So things that are potentially driving climate change come from this. So cleaning up is a big idea. Weather events are still our biggest threat. I know we're at a cybersecurity event here, and everyone wants to say the biggest threat and biggest promise is cybersecurity. There's a million products you can buy downstairs, but weather events are still our biggest problem. No matter what we say, it's still our biggest problem that we will have weather disasters all the time. I said insane load growth is still really reliable. You're still in here being served by lots of power and a very large load center in the US. You're not worried your hotel won't have power tonight. Well, actually, given where we're at, you might. But it's still pretty reliable. We're still the most reliable electric delivery system in the world. We are still very fortunate to have it. Anything I say about this, we're not failing. We're just having some challenges like everyone else. But this is a map just from an open source tool that shows us where all the power outages are in the US at any given time. Even just, I think this was yesterday actually, but 600,000 people didn't have power because of a hurricane rolling through. Actually not clear what was happening in California at the same time, but here we are. But if you look at that map, there is challenges going on. There is weather, people lose power. I will say a lot of those people, because of a weather event, they'll have power back by today. That map will probably look very different. Somebody will have rebuilt something, it will be back. But any given day, we have outages that look like this. Again, we're trying. Renewable energy is appearing everywhere. I work for a .gov, so we talk a lot about the critical sectors. So if we look at every critical sector, we might say, well, this is an electric sector, this is the energy sector only. We're putting it everywhere, so it's everyone's problem and everyone's solution right now. We have agriculture looking at something called agrivoltaics, which is putting solar in agriculture. Walmart's, I believe, the single largest solar owner in the country. They have solar on every Walmart roof. Water plants, wastewater treatment are all looking at using solar storage, other things for backup generation. There was a recent funding round that gave, I believe, 144 rural hospitals are going to be swapping over from their diesel generator sets to batteries, essentially, for backup generation from now on, which, you know, there's trade-offs there. Most of our communication towers probably have a solar and storage site on them now, as opposed to some type of diesel generator there. If you go look at them, half of them will say the name of a large battery company on the side of it, because that is what's the backup generation. And again, prisons as well. I've jokingly put an Alcatraz in here, but a picture of Alcatraz with solar on the roof is kind of astounding to me, actually. So it's everywhere. It's every sector. Everyone is doing something in this space. So the security of the renewable energy side is one of the most critical points for me in the future for digital transformation. Again, this is a complicated graph. Remember, I'm a scientist, so I'm going to put things on here with graphs and all of that sort of stuff. One of the big things I work on is batteries and energy storage systems. I'm going to give the positive thing that they have been saving the day for the last few years in lots of different places. They're one of the good thing that's been happening. In fact, in Texas, there's been, I think 17 different events where batteries have ramped to save the system, including for the surprise sunset. They're ramping to save the day when we're having challenges. Heat events, emergency discharge in California of batteries avoid these bulk outages. Taking some reliance away from those customers to turn off their AC is really important. And they're providing backup generation to disadvantaged communities all over the place at this point, which is wonderful. They have lots of technical features that make this good. They ramp really fast. They're necessary. I am a big fan of batteries at the moment. But to give an example of what I work on and what this means for our larger electric grid, Again, we had, this was a couple of years ago, right in the middle of the pandemic. There was a huge dry lightning storm that happened where I live, or where I lived at the time. And that's actually a real picture from the lightning storm. It hadn't rained. It was just a giant dry lightning storm. It did set off some of the biggest fires that California ever saw. If any of you know the Bay Area, the fires essentially stretched from just north of Livermore all the way down to the south of the Bay Area, which was, if you think about a wall of fire on the right-hand side of California, that's not great. During that lightning storm, the city had lost a very large power transformer. I'll talk about supply chain in a second, but getting large power transformers at the moment is relatively difficult. And spoiler alert, getting them all from China is also relatively difficult at the moment. It will take a number of months. It was 100 degrees. They'd called for a rolling blackout already because of this. Then there was failures all over the place. The wastewater plant also failed because it turns out their diesel generator didn't kick in when it should have, and it failed over. So essentially the city was kind of hosed at this point already. And again, there's been a lot of work on this. Everyone has now worked on this resilience plan, so it's a lot better for the future. There was also a big problem. That fire at some point turned around and started heading for the military base and a national lab and a few other places that were fairly critical to our operations. And this was where we started to see where this digital cyber world is coming in. We have had various cyber attacks, not during this event, but various cyber attacks are being targeted during weather events just now. I've seen probably 3 or 4 different occasions where during a large hurricane or a large storm, people would be hit with something like ransomware on a system. There'll be some other event happening. It's a thing that is happening. So it's been a challenge. Again, everything happening all at once. I'll tell the funny story on the side of this is in the middle of this event, there was an announcement that California was going to go all electric vehicles by, I think it was 5 years from then. There'd be no more gas, they were saying. Like, cool, the city hasn't had power for 3 days and they're about to evacuate because of a wildfire. Did we think electric vehicle announcement at this point was a good idea? Like, communication is key in this case. But so what would that mean now? And one of the things we have to do, if there is a very large event, be it caused by cyber, physical, whatever else has happened, there is this thing called black start, which means the system has to restart from dark. It's a really important thing that we plan for. We know how to do it. It's a thing that we have plans and people are very, very capable of doing. One of the things it hangs on, though, is us being able to do manual events that can force parts of the system back online. Most large generators should have some form of black start generator attached to them, meaning that generator can spin up on its own without any power to help power the other generator that does need power to spin up its systems. So when this happens, say we lose the whole eastern seaboard, for example, that has happened, we've got a series of things we do. Like a field crew goes out, they're usually staged. People are really good at staging field crews just now. They'll stand out and they'll wait for that storm to pass, and then they can go out and start doing the fixes that are needed before we restart anything. Florida's excellent at it. You'll see people waiting for, the storms are going through, they're waiting, they're gonna hang out there, probably go drinking in the hotels, but gonna be hanging out there, and then they're ready to go as soon as the storms have passed. Once they do all the actual manual fixes, they go out and have to look. You have to actually go physically see what's fallen down so you can rebuild it. So they go out and look, rebuild that, get the things back together, start bringing on the major generators, and then start bringing in small pockets of load. So key points that we have here, we have giant transformer yards, things that just sit there waiting for equipment-wise to go back onto the system. We do have these field crews sitting there waiting. We have humans that go out and do things, and the manual processes that pull it back together. So in this new sort of cyber-physical environment we're talking about, here's a use case, black start in industry now, or black start in industry a few years from now. I'd mentioned robot dogs. In my vision of what this might look like in future, and when we're looking at the substations or anywhere else for damage, imagine you need all your robot dogs to go out and swarm around and try and work out what's actually broken and feed that data back to someone so they can assess what's broken and what equipment they need. That data is going to have to go somewhere. Your robot dog, with all their pictures, are going to have to send information to a data center or to someone in the cloud or somewhere to come up with that AI analysis of what's damaged. And then also do a cyber assessment. We don't always know exactly what caused the power to go out at that given point. So imagine they also have to assess this equipment to work out, did cyber have anything to do with this? Was there an attack? Did someone do something during this event? Years ago, we did run some exercises where we were simulating a black start exercise on an island. And there was various things embedded in devices. We'd have the traditional power systems engineers, which I'm still a traditional power system engineer, but we'd have them running around and tell them, your goal is to get the power back onto that critical load facility that's a hospital. And usually that field crew person will go out, they'll know the steps they're going to do, they'll go to manual, they'll get things set back on, and they'll get it back. That's their goal. We had someone run out and do that. He was kind of saying he's going to do it, that's his mission. They're very mission focused, excellent people, field crew are wonderful. We didn't tell him he probably needed a cyber person to go with him I say cyber person, but anyone qualified to say, do not just turn back on that relay right now, hold on a second. So he did, and it bricked everything, because that was the attack that was set up to happen if they turned back on the power without cleaning up the device or setting it back to gold. So they essentially managed to brick the system as opposed to restarting everything. And if that happens, that could take hours longer to get anything back on, or days if we need to get new equipment. So when I was looking at how this would look in the new dependencies world, batteries would need to be charged on those robot dogs for 3 days. So are you planning for that? We need data centers up to be able to actually process and do the damage remediation here, because we need something to process that data. It's no longer a human task. So assuming that it was planned for, that your services would have ported to somewhere else because the data center was potentially down in this region, okay, we need that up. We also need communications with throughput that they can actually get all that data to somewhere else. So how do we determine in this whole black start process where the load location is most important? Do we now reprioritize that we need to get our data centers back before, say, the hospital? Like, what comes first? Then, like, all the other pieces would be coming in here, but we also potentially need an additional yard of equipment for all this power electronics stuff I'm talking about, which isn't necessarily sitting out there outside. Where do we keep all the new power electronics devices that we need to install? Then also dispatching teams that are potentially both cyber and physical. We talk about workforce problems enough already. There's a lot of people saying we have workforce problems. We also have it here. We don't have these teams that are all going to be paired for this large event. There's some people that will turn up from a cyber mutual assistance perspective, but in this massive event, we need more people to be helping with this. So try not to be too doom and gloom. We probably would get the lights back on somehow right now, but I'm not saying that this is where we're at now. But there is this future coming, and that's what I'm talking about. So I've been all doom and gloom. So what can we actually do? How are we working on this just now? We really need the ability to prioritize these trusted systems. Again, we need trusted cyber physical systems on our system so that we don't necessarily run into those major cyber events at the same time as all the weather events. I live in two different worlds. Right now, I work on a lot of things in cyber-informed engineering, which is building cybersecurity into our engineering design processes, so we don't need to worry as much about the big thing happening all at the same time. Devices, we absolutely need to make our devices more secure as they're built, not secure them afterwards. So security by design, that's a common thing now said from the DHS program. I do believe that's important. I don't actually know we can persuade the massive amount of Chinese suppliers to their electric grid to do secure by design for the US grid at the moment. If we could, that would be helpful, but we're not going to be going that direction for a while. So how do we do all of these things at the same time? Put wrappers around the things that we're most worried about, do secure by design, do secure by default, and then also do cyber-informed engineering. There's lots of words. So this program is one of my favorite programs to work on because I am an engineer, worked in power systems. I understand we do have some manual systems we can use. I think it's an excellent process. We use design decisions right at the beginning of these processes to be able to eliminate or mitigate the worst case scenarios. Be that, I gave the examples of hospitals with batteries on them. Imagine those are all from a non-trusted vendor that has various challenges with their supply chain. Okay, putting a battery on a hospital as opposed to this diesel generator that generally works. If the failover switch works, the diesel generator usually will work. So one of the examples I give for cyber-informed engineering is our very first design decision here for the most consequential problems, which would be the hospital has no power and people die, is that we just leave the diesel generator there. Like, if we want to do this cheaply, don't remove it entirely. keep it minorly operational and don't put the other thing on it. You know, there's decisions you can make that are not just do the fancy dancy cyber thing you can probably buy down below. But we do want to do those things also. But it's an opportunity to use engineering controls around our designs. So it's essentially a landscape where we bring in together the engineers, IT and OT teams together to actually talk through what the best controls are to put in place. Often these teams are not speaking the same language. That is one big thing that we have as a challenge in this future landscape. I'm lucky enough I can translate the words between, but there's only so many of me that can do the translation, not just from Scottish to American. But we need to translate between the two words and get these digital components to really be okay. So availability and words like that need to make sense to both sides. We bring those teams together. We help accelerate the adoption of cyber by design or secure by design also. When we see a component or a piece of equipment that just can't be designed or we can't analyze its firmware, we need to change that. And so that's looking for future opportunities also. So how do we look at consequence? This is one of my favorite things to do. I do consequence analysis, like working at how bad it's going to be. But we very much look at what's the purpose of the system, how does it support the organization you're working in, what mission critical functions does it actually do as a system, and then success metrics. So one of the consequences we've started to introduce is what if you don't do this? If you're doing this design or this upgrade, do you critically need this? Like what if you didn't do it? What are you not going to be able to achieve? Be that net zero targets, a cost reduction, or improving your security. And then what consequences would you have from its unexpected actions? One of the important pieces here is to look at the engineering side of that, not just loss of comms. We have had events with renewable energy, for example, actual attacks on communication systems, meaning they had no communication anymore or visibility, but the site still was generating. It was still doing its primary function, which was providing power. It just didn't have comms. That wasn't the most critical event that had happened. It wasn't the worst case scenario for that system. So how do we secure around the most consequential pieces? Again, it's a long process. I won't go over all of this, but we look at a cloud decision framework that we've been working on for small utilities. I'd mentioned this earlier, that a lot of the small utilities don't have much of a choice right now. If they're modernizing, they probably need to go to some form of cloud, with industrial control systems as a service being a new thing that's coming up in the cloud environment. I'd love to say we're not doing controls in the cloud, but they're there, so we are doing it, so we need to make it secure. The framework that we developed is called CERIS. Essentially, it's around responsible use of cloud in OT environments. It's consequence-driven again. Everything starts with what's your baddest day with this system? How do we fix that? And then steps through ways that they can assess their deployment plans and modernization in the future against, it gives them controls for cybersecurity, for example, of, hey, when you look at your workforce, do you have anyone that knows what you're doing, or did you hope that the cloud provider was going to provide you workforce? Do you have anyone that does this, or using Geek Squad? Like, what's happening? So that's one of the things in there. The other thing that was released recently that I'm very happy to have seen is supply chain cybersecurity principles by Department of Energy. Those are essentially to help us give people a guide of what we are going to be expecting from our suppliers in future. There's a statement made from the White House on these as well. We're asking suppliers of equipment to essentially, for the electric grid, to buy into these sort of foundational actions that we need them to take for this future. There's 12 of them, or sorry, there's 8 of them. I won't read them all out, but these sound simple. The idea is that we get people to agree to, we are buying into doing this as a principle in future. Not necessarily saying we'll regulate you if you don't, but this is more of a, we will look at you and say you've actually done these things. It gives people who are buying equipment also something high level to look at and say, do you buy into this? Have you signed off on this? Cool, at least we have some degree of trust that you're going this direction and you're doing the right things at the highest level. Last part I was going to talk about is we have a cyber labeling research project. I didn't actually know that was a video, so that's cool. So we're doing a cyber labeling effort, which was this US Cyber Trust Mark effort. Which is essentially, again, like a nutrition label on your devices. When you buy something like an inverter for your house, it has a safety label saying, please don't set me on fire. This is probably good. We're aiming to have the same things happen from a cybersecurity perspective. Your device has been reviewed. It's a proof of concept for this just now. It's a demo. We're trying to get it in place. Again, one of our challenges is we don't actually have standards right now for some of the equipment to meet. Go back to energy cyber sense principles. That's what we're really trying to do there. So when we talk about supply chain security, software bill of materials always comes up. I'm very bought into doing this as well. I think it's really important. But once again, going back to our challenges on supply chain, when everything's from different countries that we might not have a great relationship with at the moment or being on the verge of various things happening, can we trust where the S-bomb came from? We need trusted suppliers of these things also. So just in conclusion, I'm open to questions as well in a few minutes, but it's happening now. We're changing things. You can see robot dogs in substations. You can see other things. We have cyber events happening. We haven't had a cyber event that has caused the lights to go off in a utility in the US. So I want to be clear on that. There hasn't been one. So when people start saying everything's going to happen, I see someone knocking on wood, but that's metal, so that's not going to work, man. But there hasn't been an industrial change. Sorry, there hasn't been a cybersecurity attack that's turned the lights off in the US. So we want to keep that going. We really need different disciplines to work together on this. You might wonder why a power systems engineer ends up talking to you at Black Hat. That's why. You need people like me, essentially, to be talking to you about how these things work. So that's my world. But again, one of the things we've been thinking about is how do we pull cyber plugs, and how do we do that? When we run pull the plug events on the electric grid, at some point we need a pull the cyber plug event so people understand what that actually looks like. I was going to make a joke about that happened recently. I probably shouldn't, but here we are. But again, that's me today. If you want to look at any of the related programs, I put these up here. They're easy to find. Google any of cyber plus DOE and you'll find a number of these. But just wanted to put up some programs for people to look at just in case. But that is me. But thank you. And any questions? And if you do have questions, please use the mic, because I can't hear you otherwise. And if you don't, I can talk to you at the end, which would be fine. But I also can't see, so you're just going to have to start talking. So.
Well, thank you so much for the presentation. I don't know if you can hear me. I was curious, I think I heard a sound bit that you mentioned there was a surge in cyber attacks during weather events. Could you speak a little more about that?
Yes. So there have been there have been attacks during weather events that are mostly based on sort of ransomware or financial. There haven't been a power outage caused by those. There have been attacks during weather events that were ransomware based. Again, it's people using your worst day against you with things that weren't set up in the right way. So that's really what we've seen. I've seen about 12 of those in the past 5 years, but effect on power has been none. So
thank you.
Yeah, I did have one question. This relates more to the infrastructure side as opposed to the cyber side. You did mention that we do source a lot of these materials from overseas, a lot of the manufacturing capacity, not just for the big green boxes themselves and the associated components, but the things that make them up, the electrical steel, the cooling oil, and things like that. I don't know, China, India, Russia, Eastern Europe is where most of that stuff is coming from. Is there any wide-scale effort that you're aware of at the national level to start bringing some of those industries back to the country so that we have some controls? Because, I mean, you mentioned a matter of months to build some of those boxes. None of them are standardized for the most part. They're all custom jobs, and you're probably talking 12 to 18 months a piece on them. Yeah, or more. You know, what are you aware of any efforts to bring that sort of industry back to the United States and manufacturing capability as well? I guess the other question I'd ask about that is, you know, would that be categorized as national security critical and managed in that manner?
There's been about $30 billion put into bringing various things back over the last few years. I think we're in kind of two worlds at the moment. Some of this is personal opinion. Mm-hmm. We can bring back some of the more critical pieces, but can we afford to keep making them here is the other question. Yep. Power expense has gone up drastically in the past few years also. So I think there's opportunities for us to secure around a lot of these things, just doing the right things in the first place and how we install them versus bringing all of them back at this point. I think we need to do all of the things, don't get me wrong. This is not a good scenario for supply chain at the moment. But there is a lot of money going into trying to bring back components that's prioritized as well. So when you look at batteries, for example, critical materials, the actual electrolyte was prioritized first, and then we have other components following that. So say the control PCs coming next, then chips. The CHIPS Act is in place now to bring back those PCs. I think it's prioritization that's one of our challenges as well, because not everything can come back. I think everyone needs to tell all their kids to go work in manufacturing so that we can actually go work out how to get enough people to actually do this. So,
Thank you.
You mentioned, touch wood, that so far the US hasn't had any cyber attacks on energy systems, but there has been some significant attacks in Ukraine and Eastern Europe and even in Australia and the Middle East, places like that. Are there any key takeaways that you hope the US has taken away from some of these recent attacks, particularly in Eastern Europe, to sort of get through to the government that this needs to be a higher priority?
yes, every time something has happened, there are key takeaways that have came from a lot of the DOE work that we're doing and DHS. We bring all of those things back and try and apply it. There are critical differences in how different people's systems are built that mean things affect potentially us differently as well. But yes, there's people from both sides working to help when those things happen also, and then bring the lessons back. So there's a lot of them. So but yeah, there's been a lot of things. How we build the protections in so it doesn't happen is one. How we prioritize. The fact that we are moving away from going to manual is one of the lessons learned that's kind of important, because one of the things that's helped is everyone can go to manual still and bring systems back online. So that's one of our lessons learned, is we need to do better as we get away from that as well. So I guess I can't see at all, so just people start speaking at this point.
Hello. You mentioned that battery storage was critical to the grid. I have two questions. What percentage of that market does Tesla represent, and how important are they as a supplier? And also, is there any specific cybersecurity concerns that are directly specific to battery backup as an element of the grid?
So batteries and Tesla, I mean, percentage-wise, interestingly, new vendors for batteries pop up once a year. So Tesla themselves, I believe, are probably they're about a third of our installations at the moment. There's a lot of it, but everyone has this massive interconnected chain. So if you open up a battery system, you might find a Tesla cell inside another system as well, or Tesla may have other cells inside their system that they're using. So talking about any one company in batteries is not an easy thing to do anymore. And from a concern on how batteries work and what they're operating, control systems for them, in my perspective, are more concerning. Again, same thing. We can secure around a lot of these things. We just need to actually do it, is the other. But firmware updates are one of the things that I have a whole other talk going on, so you can come to the other one. But firmware updates are one of the big things. What saves us with batteries also can hurt us. We do remote firmware updates on a lot of these things because they're all over the place. So that style of update can be a challenge and a solution to a lot of problems. So.
Thank you.
I have one question. First of all, awesome content, but as we have compliance in banks, hospitals like HIPAA, PCI, all those, is there any way to enforce or have some sort of compliance framework for utility providers so they can enforce the security around those?
We have NERC-CIP, so we have this thing called critical infrastructure protection that is enforcement of all of these, enforcement and compliance with certain cybersecurity controls based on how critical you are. A lot of the newer systems have not yet fell under that. They're not considered NERC-CIP at this point. There is a future regulation coming in for the newer PCs, for the new renewable energy sites as well, that will start bringing in some of those owner-operators also to that as well.
Thank you.
Dr. Stewart, Joe Sisso, large energy utility. Quick question. Given the Section 889 prohibitions of the NDAA and the changes that are coming, should we expect that over the next few years that prudence in procurement will also include conformance to new standards as they start being applied to the state level?
So in the NDAA Section 889, there is also Section 154, which banned 10 different companies that are selling batteries to the electric grid. Also, again, based on DoD funding for those. It's changing. Rip and replace or banning vendors is not necessarily going to fix any of these things from my personal perspective right now. I'm sorry if anyone's writing this, but that's my opinion. We have too many vendors to deal with. Building and forcing them to have basic security practices would be my perspective rather than trying to remove or stop things going there. I think we're creating somewhat distractions by banning things as well, and we should maybe be going a slightly different direction. But the landscape is challenging. Things are changing every year, so we're going to have to keep up with this. I don't necessarily think that's going to be the way that we end up going once we realize how many things we have. So I think one more and then we're done with time, sorry.
So we have a large security in-depth approach. However, a gap I see is real-time security for PLCs. At this time, I know the move is to go towards IIoT, but in the meantime, do you have any recommendations for securing PLCs?
That's a really, really long question for right now. I think that might be one we take offline, and since we're out of time, that might take a bit longer. So yeah, but I think we're done with time. So thank you very much, everybody.